We're going to practice two more rules today. It's called the product rule and the quotient rule, and these are for functions where functions are multiplied together or functions are divided. So first we'll talk about the product rule. Let's say that you have a function h of x, which is f of x times g of x. So that's two things multiplied together. When they're a function, it's things with x's with them. Now, if you just have a number, you could always find the derivative of the function and then just put the number with it. But when they're both functions, that is a little bit more of a process. So if I want to find the derivative, I'm going to write out the rule first. And then I'm going to show you another way that I remember it. Basically, this is saying take f of x, find the derivative of g, multiply it, and then add it to g multiplied by the derivative of f. And so the way I remembered it when I was taught is like this. First times the derivative of the second plus the second times the derivative of the first. Now, you can do it either way, whatever helps you remember it. This is just sort of, whenever I'm doing it, I just sort of say that every time, because that helps me remember what we're talking about. It's always one of the functions multiplied by the derivative of the other, and then plus the other function multiplied by the derivative of the other. Just make sure you have a plus. Quotient rule does change that, so product rule has a plus. Alright, let's look at some examples. So we're trying to find the derivative here. Notice that you have x squared multiplied by 2 to the x. Both of those are functions, so we're going to use the product rule. And we start off with the first function, which is x squared, multiplied by the derivative of the second. Okay, the derivative of 2x is ln of 2 times 2 to the x. Alright, and then we add the second function, which is 2 to the x, times the derivative of the first. Okay, derivative of x squared is 2x, not a power. And so this is what you get. Now, the hard part, I think, about the product or quotient rule is that there is some simplification involved. So once you get your answer, you're going to look at your two parts and see if you have anything in common. Notice that they both have a 2 to the x, and they both have an x. So what we're going to do is we're going to factor out an x and a 2 to the x. And then what we'll be left with is natural log of 2 and the other x, so x natural log of 2, plus, and then you'll be left with a 2 here. And then that'll be the final answer. I'm sure the question is, are you really going to count off, Ms. Hines, if I don't factor it out? Well, at this point, I think it's really important to factor it out. So I will be looking for that to be part of the problem. All right, here's another example. Similar kind of problem. There's the first, there's the second. So let's find the derivative. First times the derivative of the second, plus the second times the derivative of the first. Alright, and then we look at it and we decide, is there anything in common between the two pieces? Alright, I can say that they both have an e to the x. Now these other parts, there's nothing in common because it has to come out of all of that at the same time, so none of that comes out. So all we're going to factor out is an e to the x. We're left with 3x squared plus 5x plus 6x plus 5. And because that works out that way, that means that I can combine these two terms. So usually by factoring something out, something looks a little bit more simple. Alright, this particular problem looks like it would be the product rule. You do that one and then that one. I will tell you, when you have something like this where it's just x's, there's no e to the x's or 2 to the x's or other kinds of functions, I actually think this one is easier to multiply it out first, x squared times x, x squared times 2, 4 times x, 4 times 2. Okay, there's nothing to combine, so I don't need to rewrite that. And then to find the derivative, it's really, really easy, and I don't have to use the product and quotient rule because the derivative of x to the third is 3x squared. The derivative of 2x squared is 4x. Derivative of 4x is 4. Derivative of 8 is 0. It was much, much easier on this problem not to use the product rule. So just because two things are multiplied together doesn't mean the product rule is the right way. It just depends on what kind of function that you're looking at, and if it's easier to multiply it, you should multiply it first, then find the product, or the derivative. Alright, let's talk about the quotient rule. So, let's say that we have f of x over g of x, and I want to find the derivative. Alright, I'm going to write out what the derivative is, and then I'll write it how I say it. So other than the fact that the bottom is squared, the top is actually very similar to the product rule, except there's a minus. So just notice that. Here's how I say it. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. It just helps me to remember that I start with the bottom. With product rule, the order doesn't matter really since it's a plus, but with quotient rule, the order does matter. The bottom one is always whatever the bottom is, and then minus the top one. So, okay, let's look at some examples there. Start with the bottom. Multiply the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Now here again, simplification is important. Looks like I can take out e to the x's and one of the x's here. So I'll be left with x e to the x. And then when I take it out, I'm left with x minus 2. Go ahead and square that. That's x to the fourth. And here's why that it's important to do that. Usually something will cancel. I can get rid of one of those x's. And so that's the simplified answer on number 4. Alright, number 5. I know it's a quotient because things are divided. So bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Alright, I could factor out something on top. Maybe a 5 and an x. So if I do that, I'm left with x to the third plus 1 times 2 minus x times 3x squared over the bottom. And to save room, I'm not going to write the bottom again. What we would do next is we'd go ahead and work out this part right here in the parentheses. 2x to the third plus 2 minus 3x to the third over the bottom. And then one more step since these are in common. 5x times negative x to the third plus 2 over x to the third plus 1 squared. On this problem, I think it probably would have been okay at this step right here to multiply out first and then factor out what's in common. But it's just going to take practice to see where it would be easier and where it's not easier. Nothing cancels at the end, so that's the final answer. Okay, let's do this one. Bottom times the derivative of the top, which is 0, that's okay, minus the top times the derivative of the bottom over the bottom squared. All right, 1 plus e to the x times 0, that's 0. I don't even have to write that. Minus 1 times e to the x, that's minus or negative e to the x, over 1 plus e to the x squared. And then that's your final answer. There's nothing that you can cancel because the 1 plus e to the x is in parentheses and it's being added. Okay, I have 2 problems for you to try, one with the product rule, one with the quotient rule.